Hello everyone. In this video we're going to be solving a geometry puzzle. Two circles and a semicircle with radius 1/4 are inscribed in a quarter circle with radius 1 as shown. Find the radius of the purple circle which is shaded. Awesome. At this point, if you want to pause the video and just give this problem a try. Alrighty. So we do have a quarter circle with radius 1. And then what we're going to do is, here's the plan. To find the radius of the purple circle, we're going to find the radius of the green circle first. And then we'll work with that. Okay? So let's go ahead and get started. As always, we're going to be making some important connections. So let's start with that. I'm going to go ahead and connect the center of the orange semicircle, which is the only semicircle that we have, to the center of the green circle. Okay, so let's go ahead and do that. I think that will be good. Okay, awesome. That's one connection I need, and then I'll drop a perpendicular from this point. Let me go ahead and do that. Like this. Okay, and then that'll be a 90-degree angle, obviously, right? So that we can use the Pythagorean Theorem. Okay. And then another important connection that we need to make is going to be this one. The center, which is not clearly seen here, right? The center of the quarter circle, and we're going to connect that. Actually, we don't really need this much of a connection. Let me go ahead and redo this. So I'm going to go ahead and reconnect these. So I'm thinking I can probably stop here and then make this long connection because I need to go through that center and I don't want to make it too confusing. So like something like this maybe. Here we go. Okay. All right. Awesome. Great. Now, what does that give us? First of all, start with the known values. We do know that the radius of the semicircle is 1/4, right? So this is 1/4. Great. This is also 1/4, obviously, right? Now, we do not know this one. Let's call that R. Okay. And then this is also going to be R. Now, what is this length? Well, let's go ahead and designate this one. Let's call this X. All right. And this will be R as well. Awesome. Okay. So notice that we do have two right triangles here. All right. So let's go ahead and write down our formulas for both of these. So let me go ahead and switch here. All right. So the first one is going to be, I think you can probably clearly see from here that the whole thing, if I call that whole thing X, this is also 1/4, by the way, right? So this part is going to be actually what? X minus 1/4, right? Because from the X, we're just subtracting the 1/4. Great. So first we can go ahead and use this right triangle here. Right? Okay. What do we have? We have X minus 1/4 squared plus R squared. Okay. Now we got to find that length, but that's easy. Look, this is 1/4, this is R. So the total would be 1/4 plus R. Awesome. So this basically gives you what? A relationship between X and R, and what you can do is you can actually simplify this expression, right? Well, R squared is going to cancel out, so you'll hopefully get a simpler expression from here. So let's go ahead and simplify this a little bit. This is going to give us X minus 1/4 squared. And then if I just go ahead and write it as R squared, and let me expand the right-hand side. 1/16 plus 1/2 of R plus R squared. Okay, so R squared cancels out, which means that we kind of have like a relationship between R and X, and R is linear, not quadratic. Okay, cool. Now, this doesn't really give us much at this point, so let's go ahead and leave it like that, and then look at the other triangle. So, what does the other triangle give us? Well, that's the kind of like the bigger one, right? This one here. What about that one? Well, that one has a base of X, right? So I can just go ahead and write it as X squared plus R squared. Now, what is this length? From this point to that point. Well, we know that the whole thing is 1 because, as you see, the radius of the quarter circle is 1. So if you subtract r from it, so then this piece is going to be 1 minus r, right? I know it's kind of hard to see, but that's just 1 minus r. So let's go ahead and write that down because that's really going to simplify this process. Awesome. So we're going to be getting something nice from here. X squared plus r squared is going to equal 1 minus 2r plus r squared. Beautiful. R squared is going to cancel out. Then we're going to be getting x squared in terms of r, which means we can square root both sides, right? And 2r needs to be less than 1, obviously. R is less than 1/2. So we get x is equal to square root of 1 minus 2r here. Awesome. Now, how does that help us? Well, we do have another relationship here. So what we can do is we can replace x with what it is in terms of r and then solve this equation. So let's go ahead and work off of that, knowing that x is equal to the square root of 1 minus 2r. So it's going to look like this. The square root of 1 minus 2r minus 1/4. Such a beautiful expression, right? And that'll be squared. And a thing to add equals 1 over 16 plus 1/2 of r. Beautiful. So what we got to do now is solve this equation for r. So let's go ahead and simplify this a little bit, right? If we simplify, this is going to look like what? 1 minus 2r minus 1/2 of 1 minus 2r square rooted plus 1 over 16, which is nice because that's going to cancel out. Beautiful. And 1/2 of r. All right. So these two numbers are going to cancel out. Beautiful. Now, what we have is a radical. So let's go ahead and isolate that radical. And how can I do that? I'm just going to add it to both sides. And then, so it's going to look like that stuff is going to be positive on the right-hand side. So I can take it and put it on the left-hand side again, kind of switch sides. And then we're going to bring over the 1/2 of r, subtract it from the negative 2r. That's going to make us negative 5/2, right? Negative 5/2. So, but we also have a 1 there. So it's going to be 1 minus 5/2 of r. All right. 5/2 of r. Yeah, something like that. So now we're going to be squaring both sides. And what we do, why we do that? Because we need to get rid of the radical. So we need to do it. So if you go ahead and do that, this is going to give us 1/4 of 1 minus 2r is equal to 1 minus 5r plus 25 over 4 times r squared. So let's go ahead and put everything on the right-hand side where the r squared is positive. So I'm going to be getting from here, like if I distribute, I'll be getting negative 1/2 of r. That's going to be negative, so I have to add that. So it's going to be negative 5 plus 1/2, which is going to be negative 9/2, right? Okay, so I'm going to be getting negative 9/2 of r. And then I'll have 1/4. 1 minus 1/4 is going to be what? 3/4, right? And the whole thing is going to equal 0. All right. So hopefully we didn't make any mistakes, so we can calculate this easily. All right, let's go ahead and solve this equation. Multiply both sides by 4, which will simplify the process. That's going to give us 18r, and this is going to give us 3. Awesome. I mean, obviously, this is not factorable. The roots are not rational. You can tell, or by discriminant, you can tell. So let's go ahead and use the quadratic formula here. R equals negative b plus minus the square root of b squared minus 4 times 25 times 3. Awesome. 4 times 25 equals 100, so that should make it easier. And 2 times a is at the bottom. Cool. So 18 squared is what? 324, and this is just 300. Beautiful. Isn't that great? Okay, awesome. And their difference is going to be then what? Well, it's going to look like this. The square root of 24. Let me go ahead and do that here. So we skip a step there. It's going to be 4 times 6 square rooted. So it's going to be 2 root 6. And as you know, I can simplify r here by dividing both sides by 2. But then I can go ahead and split it up as well, right? So let me go ahead and do both at the same time. So r is either 9 minus root 6 over 25, or r is equal to 9 plus root 6 over 25. And at this point, I kind of need to decide what r is. Let's take a look. So if you go back to our original picture, first of all, you know that r is less than 1/2, right? In order for that to be defined. So is this less than 1/2? Well, if the top is actually less than 12.5, so the question is 9.6 less than 25 over 2, right? That's probably the right question to ask. So in other words, is square root of 6 less than, is square root of 6 less than 25 halves minus 9, which is going to give us 7 halves, which is 3.5. So this is 3.5. The question is square root of 6 less than 3.5, right? That's the type of question we need to ask. Well, if you square both sides, you're going to get 6 less than 3.5 squared. As you know, 3.5 squared is 12.25, and that's actually true, right? So this actually gives us an answer less than 1/2, but I think that's kind of expected. So, but if you think about it, square root of 6 is like 2.4-ish maybe, right? 2.5-ish, pretty close to 2.5. So let's say it's 2.4, right? So if it's 2.4, great, okay. The sum is going to be like 11.4, and if I divide it by 25, it's going to be something close to 1/2. Okay, so is it reasonable for R to be close to 1/2? Let's go ahead and look at our picture, and let's kind of decide. Well, R is supposed to be, if you look at the picture carefully, right? R is actually not very much different from the 1/4. So it's probably unlikely for that value to be close to 1/2. So we're going to go with the other solution, but let's go ahead and check that value as well. So if the first one is going to be 9 plus 2.4, this is going to be about 9 minus 2.4. That's about 6.6 divided by 25 is going to give you something close to 1/4, and which is more reasonable. Okay, so we're going to go with this version here, right there. Okay, but here's the thing. I still need the x value, right? Okay, so how am I going to find x? Well, we were able to write x in terms of r. Remember that? X was equal to this, square root of 1 minus 2r. So now we're going to use that expression, x is equal to square root of 1 minus 2r, and replace the r with what we found, this one. Okay, awesome. So it's going to look like this then, 1 minus 2 times. If you multiply that by 2, you're going to get 18 minus 2 root 6 over 25. Let's go ahead and simplify this a little bit. Well, I got to make a common denominator. 25 minus 18 is going to be 7. So that's going to equal 7 plus 2 root 6 over 25. And you know what? This simplifies nicely. Isn't that beautiful? Look at that. This is going to be like root 6 plus 1 squared. Think about it for a minute, and you can use our shortcut as well. Factor 6 into 6 and 1, and their sum is going to be 7. Awesome, beautiful. And this is just going to be a 5. Great. So x would be square root of 6 plus 1 over 5 then. Nice. Okay, we got the value of x. Now we can go ahead and proceed to the next level and find the value for the radius of the purple circle. Great. Okay, so what we're going to do is I'm going to go back to the original shape. I probably should have copied it, right? But anyways, I'm going to go ahead and erase everything because I'm not going to need it anymore, right? Hopefully not. All right. So I'm going to get a clean slate, and then let's go ahead and make new drawings. But this time, our focus is going to be on the purple circle, right? So we're going to make our drawings a little differently. Okay, so I'm going to go ahead and connect these two centers here with the purple color. And then I'm going to drop a perpendicular here. All right, let's call the radius of this circle A. All right, because we already used R. So that'll be an A. And then let me go ahead and connect these two centers. And that looks like a squiggly line, right? Okay, this is also A. And remember, we call this R. For now, let it be R. Later on, we're going to replace it. Okay, and I'm going to drop another perpendicular here. That'll be R as well. And then we know that this whole thing was X, right? We called it X in the first place. Okay, so here's the thing. I do have a pentagon here, which can be broken down into a trapezoid, a right trapezoid, and a rectangle. So basically, that's going to be the next thing that I do, okay? Well, what do I have here? Well, I'm going to have to designate more lengths here. So let me go ahead and call this thing here H. So what I have is I have like H, I have the A, R, and X. I think I'm ready to go. And to make it, to give us some room, maybe what I'm going to do is I'm going to go ahead and erase this part because I just want to work it out here. It's going to be better. Let's do some cleaning here. Awesome. All right, let's go ahead and write things down now. And I'm going to use this color. Awesome. What do I have? Well, based on what you have, and you can draw a perpendicular line here, but I don't want to make it too confusing. So let me go ahead and do this here. So I have this kind of thing. Kind of like a maybe car. You're trying to draw a truck maybe, and this is the front part. Okay? I used to love drawing these kinds of things when I was a kid. Okay, so this is H, and if you kind of draw a parallel line here, you know that this is R. So this will be R. This will be H minus R. Okay, so what do I have there? Let me drop this perpendicular line as well, and then this is probably going to complete my picture. Okay, awesome. So now what we're going to do is we're going to take advantage of our formulas again, but I need to make one more connection because what I need is the diagonal here. So bear with me while I draw this diagonal. Okay, awesome. All right, so this will be A, and what about the rest, right? So I kind of need to know, and this is 1/4, by the way. We know that, right? Okay, and this is H. This is H. Awesome. So what do I have there? Well, I can just go ahead and write this as a really nice relationship, but let me go ahead and start with this. I do know that this whole thing is X, right? This whole thing is X here, and this is A, so this will be X minus A. Beautiful. So let me go ahead and write it down here. What do I have? Well, I do have this right triangle here that, okay, I don't want that. So I do have this right triangle here, right, that I can use definitely. So what does that give me? It gives me X minus A squared plus H minus R squared. Don't worry, we're going to replace some of these with numbers is equal to A plus R squared. Beautiful. Awesome. Okay, now what am I going to replace these numbers with? Well, I do know what X is. I do know what R is. So I can just go ahead and make all these replacements. I don't think I'm going to need that diagonal. Am I? I don't think so. But that's just the hypotenuse, and that gives me what? 1/4 squared plus H squared. Not really. I don't think I'm going to need it. Okay, cool. I think this would be good. So what is X, right? Well, X is equal to 1 plus root 6, or I can write it as root 6 plus 1 over 5 minus A squared, okay, plus H minus R. Now, what is H? Okay, that's something we needed to find, right? How do you find the value of H? Okay, I think this is where this becomes helpful, right? Okay, I think I'm going to use this triangle, even though I said that I wasn't going to use it. I do need to use it. Okay, okay. So how am I going to use that right triangle there? Well, here's the thing. I'm not going to use that. Well, it's not even a right triangle. Wait a minute. That's not a right triangle. Okay, cool. So we're going to have to back up a little bit. Here's the thing. Okay. So it's really hard to see, but you probably would say the same thing, that the radius of the purple circle and the semicircle, they're not equal, obviously, right? The way the circles touch each other, you could probably tell, right, that they're not going to be the same values. So what we need to do then, which one is larger, right? Well, this one is going to be slightly bigger, this one. Why? Because of the way the circles touch each other. Take a look at that. It touches here, it touches over there. So that kind of gives us more room here, because when you see, if you kind of draw a line from here, you'll probably understand better. But anyways, the idea is that the radius of the orange will be actually larger. So let me go ahead and redraw that part, because I lost that one. Well, I already have it. I don't think I need it anymore. But anyways, okay. So let's go back to our orange. So what I'm going to do here is actually, let me go ahead and finish. Well, I'm looking for H. Okay, so here's the idea. What is the idea? I'm looking for H. So how do I find H? Okay, here's how I find H. Since this 1/4 is slightly larger than a, so I do get a little trapezoid here like this. Okay, it's kind of hard to see. This is 1/4, this is a. So when you drop a perpendicular, this little tiny piece here is going to be 1/4 minus a. And I'm sorry about that, it's very small. Okay, so that gives us one piece right here. And then the height is h, okay? The height is h, cool. And the hypotenuse is basically gonna come from the sum of the radii of these two things. So this is basically, guys, 1/4 plus a, or a plus 1/4. This is a, this is 1/4. I hope you can visualize that. So to keep a long story short, 1/4 minus a squared plus h squared is going to be 1/4 plus a quantity squared. All right, so from here, if you use our identity, subtract this guy from the other guy, you know that it's going to be 4 times x times y, which is a. So from here, h is going to be square root of a, right? And we can just go ahead and replace it with square root of a. So it's going to be square root of a. We know the value of r is 9 minus root 6 over 25, and that is squared. And then a plus r is just going to be a plus r. R is 9 minus square root of 6 over 25 squared. All right, so to keep a long story short, I guess this will be the expression that I will be working off of. Okay, so what I can do is I can just go ahead and take that and work it out here. So for that one, I'm just going to make some room here for myself. Just too lazy to move down and copy that. So I'm just going to clear some area here and then do my work. Okay? All right. So what am I going to get from there? Well, I'm going to get a quadratic equation, right? Well, here's the thing. If you go ahead and square both sides, you're going to get a squared here and a squared here. They're going to cancel out. Good grief, right? That's nice. Then some numbers are going to be squared, which are going to be like radicals. And then when you expand this expression, let's go ahead and just do that so I can show you what it looks like when we do. That's just part of the equation, by the way. But if you just square this part, you're going to be getting something like a minus this guy multiplied by 2. So I can write it as this times the square root of a plus this guy squared. Okay, I got to square that guy. That's going to be gigantic. Awesome. Even this part is kind of cumbersome to deal with. And plus, to make matters worse, when you squared this, you got another radical. So you have to isolate that and then put everything else on the same side, on the other side, and then square both sides. And you're going to have to deal with lots of radicals. I don't really want to waste your time here. So to save time, I did the work for you, right? And here we go. I'm going to give you the answer for A for free. All right. So the radius of our purple circle, finally, A, is going to equal the following. Ready, set, go. Okay. It's going to equal 57 minus 2 root 6 minus 4 times the square root of 153 minus 33 root 6 all over 75. Don't you love this? Isn't that beautiful? Wow, this is awesome. Okay, such a radical expression, right? So radical. That's why I wanted to save you the trouble. I don't think you want to do this. But if you want, you can try this. What is the polynomial equation that has this as one of the roots with integer coefficients with the smallest possible degree? You can go ahead and give it a try and you'll see that a lot of complications will occur. Anyways, thanks for watching. I hope you enjoyed the video. It was kind of too radical. Don't forget to comment, like, and subscribe. And see you in the next video. Take care. Bye-bye.